Hello everybody, in this video we are going to solve another problem live from LeetCode's top interview 150 problem list. So far we have solved all the problems up to longest substring without repeating characters. If you haven't checked out my videos on those problems, please go to my channel and check them out. Today we are going to try to solve the next problem, which is substring with concatenation of all words. It's classified as hard. So we'll try our best and see what happens. Okay, let's read the problem and make sure we understand it. We are given a string S and an array of strings words. Okay, all the strings of words are of the same length. Okay, so all the strings in this words array are of the same length. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. Okay, so they are saying, okay, for example, if words array has 3 strings, each of them is length 2 in this case, A, B, C, D, E, F, then A, B, C, D, E, F, A, B, E, F, C, D, C, D, A, B, E, F, and so on are all concatenated strings. Okay, that makes sense basically. But A, C, D, B, E, F is not a concatenate string. Yeah, because you basically have to concatenate these 3 strings in some order, and that is a concatenate string, but you cannot obtain that by doing any order of concatenation. Okay, makes sense. So I understand what a concatenated string is if the words array is given. Let's see what the problem is. Return an array of the starting indices of all the concatenated substrings in S. I see. You can return the answer in any order. So I think what they're asking us is that given S, basically it's a problem to find a specific substring inside S, but the substring could be any of the concatenated strings given the words array. Okay, that is an interesting problem. Let's make sure that's the right understanding by looking at the examples. So the first example is the input. The string S is bar foo the foo bar man, and the words array is foo bar. Okay. And they're saying the output should be 0, 9. Basically, okay, so before we read the explanation, let's figure out ourselves, right? Okay, so foo and bar, which means there are 2 concatenated strings possible. So one sec, let me do that here. If the words array is foo and bar, then basically we can get few concatenated strings, right? So strings or concat strings, we can get 2 concatenated strings because there are 2, so there are 2 ways. First you put foo, then you put bar, or you put bar and then you put foo. And then the problem is, hey, does this string appear as a substring in the main string, or where all does it appear? So this is the main string, right, S. And then we find out, okay, where all does foo bar appear in S? And the answer to that would be foo bar is here, right? So that would be 9 index. Yeah, 1, 2, 3, 4, 5, 6, 7, yeah, 9. And then the second question will be where all does bar foo appear in S? And the answer would be 0 in this case only. In this case, there is only one instance of each of them, but note that there could be more than one. And we are supposed to return so hence return a list that contains 0 and 9 in any order they are saying, right? So basically something like this, a logical list 0, 9 or 9, 0 or something. Okay, so I think that's the answer. Let's see here. Yeah, they are saying bar foo. It's yeah, exactly what we just discussed. Okay, so that's good. Our understanding of the problem is correct, which is always in such problems, one of the most important steps is to make sure we understand it correctly. Okay, let's look at the second problem. The second problem is the string is this, and the words array is word, good, best, word. Oh, I see. So this is interesting actually. I mean, it's mostly the same, but I found one thing interesting, and which is the word, specific word in the words array could actually repeat. So in this case, the word repeats twice, and that means the any of the concatenated strings will have that twice as well. So in this case, there are many different concatenated strings, right? Concat strings, there will be 4 factorial of those equal to 16. Sorry, not 16, that's 24. So 1, 2, 3, 4, yeah, 1 times 2, yeah, 24 different concatenated strings. Different concat strings. And for each of those, we need to figure out where they appear in this word, right? Or sorry, in this string S. Okay. That is interesting. Well, it turns out in this case they are saying there is none, but you know, if the input was different, there could be some. Okay. And the last example is, you know, we are not going to go through that in detail. We'll want to start thinking about how to solve the problem at this point. But just looking at it quickly, given this string and bar foo the as the words list, it appears in 3 places, 6, 9, 12. Oh, actually, wait. So this is a bit of an interesting example, and that's because the answers could overlap, right? So which means, okay, let's take this example for a sec. Here, bar, foo, and the, right? And here looks like, basically, if you look at the string here, the first time it appears is here, right? Which is starting index 6. So foo bar the, that is concatenation of these 3 words in some order. But then the second that appears is actually here, bar the foo. So that is overlapping with the first one. So that is, I mean, I guess that makes sense, but just to very clearly keep it in our head. And the third one appears is here, the foo bar. So that's why the answer has 3 different start indices, 6, 9, and 12. 6, 9, 12. All right. Okay. I think that makes sense to me. Now, let's quickly look at the constraints. The constraints are that the length of the string, the main string, is between 1 and 10,000. The length of the words array is between 1 and 5,000. Okay, that number dashes my hopes about one approach I was thinking about, but I'll come to that in a minute. And then the length of each word in the words array is between 1 and 30. Okay, and you know, yeah, everything basically consists of lowercase English letters. That makes sense. Okay, so let's come to the approach, right? And the reason I said that one constraint dashed my hopes is of some basic approach I was thinking is I thought that we could do exactly what I did manually here in code, which is generate all the permutations of the words array words, create a concatenated string from that, and for each of them just check in the string whether that appears or where that appears. So the reason I think that it's not practical is if the size of the words array, which is like this, right? Sorry, words, sorry about that, words array, one sec. If the size of words array is less or equal to 5,000, which means in the worst case it is 5,000, then there are at most 5,000 factorial different concatenated strings, concat strings. And that is just too many. Like our program wouldn't finish in any amount of reasonable time just to generate the concatenated strings. So we need to come up with a slightly or a very different approach, I suppose. Okay, so given that, what can we do, right? Well, I mean, the immediate thing that becomes a little bit obvious to me is that given any string, let's say we are given this string, right? We can basically we cannot do all the permutations and hence do an exact substring, right? So let's say that this is our example. I think I like the last example the best. Bar, foo, and the, right? So in that case, we cannot generate all the permutations for the reason I mentioned, or at least that's not efficient in all cases. But let's say that here there are how many words I say. So num words is 3 and word length is also 3. So which means the length of the substring we are looking for is 3 times 3, right? Because we have to concatenate every word exactly once, right? So that's equal to 9. So what we could do is we could actually at least look at all substrings in S. For all substrings in S of length 9, figure out if that substring is a concatenation of all words, right? So let me spell it out a little bit more in this case. So in this case, like I said, our S is this string, right? So in this case, let's see what are all the substrings of length 9. Rebel 0 to 8. What is the size of this? 1 second, or the length? 3, 6, 9, 12, 15, 18, 21, and 24. So which means 0 to 23, right? So 0 to 8, 1 to 9, 2 to 10, etc. And then all the way to, well, the last index is 23, and that minus 8, which means 15, right? 15 and 8 is 23. Yeah. So those are all the substrings of S which are 9 long. So bar foo foo, right? R foo foo B, A R R, R foo foo B A. Actually, I should just write one more here, 3-11, and that is foo foo bar, and so on. And the last one that we have is foo bar man, right? So we could check if any of those is a concatenation. At some point we will get that the thing starting at 6, which is somewhere in the middle here, right? 6-14, I think. Yeah, 6-14 will be foo bar the, and here we'll say true, right? Everything else was false. That false. This is not a substring. Concatenation. This is not a concatenation, and so on. So for 6 we will get true. Similarly for 9 we'll get true, right? 9 to 17 will be bar the foo, and that will be true, and so on, right? So that is our approach. But now the question is, well, that part was the easy part of this algorithm. Now the question is, how do we check whether a specific substring of length 9 is a concatenation of the given words, right? And that's a little bit tricky. Let's see. Well, I mean, one thing we could do the inefficient way, like I always say in some problems like this, like you can always first think about a way that works before we think about a really good way. So let's say we are given a string like this one. We'll take, now the problem reduces to, given a string or a substring of S, given a substring of S, figure out whether that is a concat of all words, right? I'm not going to fix those spelling mistakes for now, but okay. So let's say, example, we are given this substring, right? How do we know if that is a concatenation of foo? Well, in this case, 1 second, bar foo the, right? So, okay, I don't want to take the same order because, okay, bar foo and the, right? I mean, well, one thing we can do is we can say, okay, hey, let's just look at 3 characters at a time, right? Because all the words are 3, and let's just take those words. So 3 characters at a time is foo, and let's just take that and see if that exists in this array. If it does, we remove foo from that list because we found foo. So after we found foo, we remove foo, right? And when the remaining string is bar the, and the remaining array is bar the, then we again peel off the next 3 characters and we say, hey, does that exist in our list? And we say, yes, that does exist in our list. And then this is this, and this is that, right? And then finally, we will have empty string, and we will have an empty array, and that means it is a match. And if any of these things did not work out, if we did not find any of the substring of 3 characters inside the list, then it's a false. It's not a match, because it has to be exactly concatenation of all the words exactly once. So that is an approach. Now, if we now it hence it boils down to, okay, how do we check this efficiently, or not even just efficiently? How do we keep track of this? Well, I mean, we could just keep track of it with some data structure which allows us to remove, like allows us to find whether a specific word exists and remove that word if it exists, right? And I mean, one thing that comes to my mind in doing that efficiently is a hash table, right? So if we put all these three in a hash table, right? And remember that they could repeat the words, but let's come to that in a minute. So let's say we put bar and foo and the in a hash table, right? So this is a hash table. And yeah, so I mean, when we look at foo bar the as the string, we look at foo, we can look up the hash table for a key which is foo, and we can actually, if it exists, we can remove it, right? And then we can go forward in the string. We can then go to bar, right, at that point. So we go to bar the is the remaining one, and if that exists, then we actually remove it, and so on, right? Bar the means we are actually looking at just bar. If that exists, we can remove it, and so on. And if we basically match all of them, then we say, okay, we found a match, right? So that is now the only thing that we have to modify here is, okay, what if there are duplicates that are allowed here? Like if there was the words array was bar foo the foo, right? Then, well, there is no multi-set data structure in Java, if I'm not mistaken. Multi-set is a thing that in other languages allows you to keep duplicate keys, right? And it keeps track of it. In our case, but we can have a hash table with a with a frequency count or something, or a count of how many times they are in the words array, right? And then instead of removing it, we can decrement it, right? Decrement these counts as we find them. Like when we find foo, we can decrement the count of foo. So after this, the hash table will look like this. And we are saying, oh, we already found one foo, but we still need one more foo, right? And this would be the hash table. And after we find bar, we'll say, okay, now bar is 0, or we can even remove bar at that point, doesn't matter. And then we still need one more foo and one more the. So this is a hash table of what is expected, right? And it always starts with the full hash table based on the initial words array. So I think that gives us a completely working approach that we could try to implement and see whether it works. So hopefully that made sense. I'll try to break down the code in helpers when it makes sense. So hopefully that will help again if this wasn't clear. Okay, so let's go step by step. So what was the first thing? Well, the first thing is we need to peel off these substrings of size 9. So we need to consider all substrings of size 9. Okay. So then that size comes from, okay, so let's get a few variables here. So let's say int word count equal to words dot length, right? That is how many words we have. Int word length equal to words of 0 dot length, and this length is a method because it's a string. Words of 0 is a string. And then we say int substring length equals word count times times word length. Okay, so that's this. Basically in our example, this would be 3, this would be 3, and substring length would be 9, right? Okay, so those are there. Now what do? We say for int I equal to 0. I is the start index. I mean, I could call it start index. Start index equal to 0. This is the loop to generate all substrings of s of length, substring length, right? So as start index is less than s dot length. Actually here we can do start index plus substring length is less or equal to s dot length, and the reason is because all the 9 characters in our case have to be within the length of the string, not just the start index, right? So the start index plus that substring length has to be within bounds. And the reason I converted to less or equal to instead of less is because it is inclusive of start index. So that's why it's basically, if this would be another way to do it, right? Maybe I should keep it this way, right? Because the last index, basically imagine this to be the last index, right? I could also, I mean, I'm not going to keep it that way, but you could say last index is this, and that should be less than length, right? So anyway, so that's why I initially converted to less or equal to, but we can also write it this way, and we say start index plus plus, right? Plus plus start index. That gives us all the substrings of S, which are of length F substring length, right? SUBSTR length. Okay. So that's that. Now, what is our substring itself? Well, the substring itself is there's a substring method. Go from start index and start index plus substring length. I think it takes if I'm not mistaken, the substring method in Java takes start index and last index as parameters, and last index is exclusive and start index is inclusive, which means it will stop at 1 before the last index that we provided. That's why here I did not do a -1. Okay, so that's our substring. And I think at this point we can actually delegate to a helper. So let's say boolean is match equals let's say check substring, right? Something like that. 1 second, check substring. Okay, and then what do we want to pass? We want to pass the substring, and we want to pass the words array, and we can also pass the word length and the word count. Actually, let me do in the other order, word count and word length. I mean, the method could figure that out from the words array, but since we have obtained it anyway, we'll pass it, and that is all, right? Okay, so let's now implement this. Actually, before we implement that, and then if it is a match, okay, so we need a variable to store our results, right? And array list is a good default generally in such cases. Results equal to new array list, that, right? And we say result, oh sorry, if is match, then we just add to results, right? So results dot add start index, that is where we found a match that we were looking for. Okay, so now let's implement this method here. Well, it returns a boolean. It takes a substring. I'm going to name it subster as well, just to make sure that it's understood that it's substring of another string. May not be needed strictly speaking, but anyway, doesn't matter, just the name. Words, and then count int word count int word length. Okay. Oh, we do need that word map. Okay, we didn't create that. Okay, so we need one more. Okay, so if you remember our algorithm, we need this map, right? And it always starts with the map, which is the map of the initial, I mean the frequency map of initial, from the initial words array, and I need a helper for that. So I think you will know soon what I mean if you didn't already understand what I said there. So let me do another helper here. Private. It wants, okay, so this is the helper that creates a word hash table, word frequency hash table from the words array. I think that is a better way to explain it. And then say build a word map. Let me just call it word map, right? And all it needs is the list of words, and it will create a map, right? And the map is, the key in the hash map is the word itself. The value is how many times it appears in the words array here. Okay, so hash map string comma integer word map equals new hash map, and I think I can just do this. It should work. Okay, now let's say for int I equal to 0, I is less than words dot length plus plus I, and I'm just going to first take the word out of words array into a variable. So that's the word we are looking for to put in the hash map. So first thing we need to do is figure out if there is such a word in the hash map. If yes, then we increment the count of it, right? And if not, we put it with value of 1. So I think the way to do it would be, yeah, actually let's do the following. No, I don't need that. I can just do this. Integer count equals, so it's a count of that word, and word map dot get or default, right? If it is not there, we'll get a default word comma 0, right? So that's the yeah. So if it does not exist, if that word doesn't exist in the map, we will get 0 back as an integer object, right? And then all we need to do is we say word map dot put word comma count plus 1, right? So that should work, and here we say return word map. Okay, so that method takes a words array and converts it into a frequency map of the words inside the words array. Okay, and we need to do that once here. So let's do hash map of string comma integer word map equal to build word map of words. Okay, so we did that, and we need to pass that. Without that, it's not gonna work. I mean, the method could itself do it as well, but we don't want to repetitively do it, right? So that's why we do it once, and we pass that to the check substring function here. So I'm just going to create some horizontal space. Hash map of string comma integer word map. Okay, so I think we have that. And now let's run our algorithm again. So now we are given a substring like this, and we are given a map like this. So what we need to run is our core logic to figure out if that substring is a concatenation. So whether this substring is a concatenation of all the words in the word map, right? That's what we are doing there. Okay, so one thing we have to do is we have to create a copy of the word map, because we are going to change it and we don't want to destroy the original word map that was created from the original list of words, right? So hash map of integer, let me just call it map equal to new hash map, and I think we can just pass the existing one in the constructor, and it should create a copy of that. If not, we'll figure it out. I don't remember. I mean, I haven't done this in Java in a long time, but I think this should work. Okay, let's now run our algorithm, right? What was our algorithm? Well, our algorithm was, yeah, I think we start from 0. Well, we have to find all the words, right? So we can write the loop a bit differently. We can say I equal to 0, I is less than word count plus plus I. I mean, we really are not going to, yeah, that is how many words we have to find in the string substring, right? But our start index, sorry, so we need start index equal to 0. We are going to start from 0 in the substring string, substr string. I'm just going to call this s. Actually, it's confusing to keep calling it substring. For this method, it is not a substring. It just says, okay, give me a string, and I will figure out if that is a concatenation of all the words in the word map, right? Okay, so start index is 0. So we start at 0, and we basically, yeah, and I think we say a string. Yeah, I think good to not call it substring, because here we do need to get the substring from s. S.substring, we say from start index and start index plus word length, right? Remember, in our example, this was 3, right? So we are peeling off the first word length characters in the first iteration, and that is the one we want to look if that is a valid thing, right? So in our example, just again for my thinking as well, but to remind you guys as well, in our example where we were matching foo bar the, right? So here foo bar the is s in this method, and the word map would be bar appears once, foo appears once, and the appears once, should appear once, right? That is what is the desired map, right? Okay. In this case, basically sub str will be foo, just foo, because that is what we did by this function, right? So here sub str is just foo. Just say sub str is foo. Okay, just to kind of keep that in mind so we get our code details correct. Okay, now what are we doing? We are trying to check if foo exists in the desired word map in the first place, right? So we say let's again do this integer count equals map dot, remember let's not change word map, we should be changing the copy of that, map dot get or default substring comma substring is yes default and 0, right? Sorry, 0. So okay, so what are we doing? We're saying, hey, does this word substring, does substr even exist in this map? If it does, we will get the value for that. If it doesn't, we'll return 0 as integer. Okay, well, if count equals 0, which means it does not appear in the map, then we return false, right? That's not allowed. Because I mean every word has to exist, or every substring has to match one of the words in the word list, right? Okay, so we do that. Otherwise, it existed, so we need to update the map. Map dot put count -1. We are reducing the count and updating the map, and we are now updating our start index also. Start index is, we are moving it by 3, right? It matched, so we are going to move forward the start index, and if all of it works out, then we return true. Correct? Yes, I think it works. It seems quite straightforward after I wrote it. I was trying to get the details right by writing examples in the middle as comments. At that time, it felt the function will be much more complicated, but maybe I'm missing something. We'll see. We'll see. Okay. So I think that's that. And here we say return results, right? Okay. I'm not sure. It really seems much simpler in code than when actually I thought about it. So I'm hoping I'm not missing any crucial parts of the algorithm. Anyway, we'll see. Okay, wow, that is actually very cool. I did not think it will work the first time, at least not without compilers. Okay, let's think of a couple of more examples. What other example should we take? Let's take the example where there's a double. Okay, it actually, yeah, let me change this example into the one that has more than one, or that has duplicates in the words array. So let's add it here. One sec. And then foo bar, bar, and what I'm going to do is I'm going to modify this so that foo bar the bar the foo bar. Yeah, this should also return 6 9 12, I think. Yeah. Invalid test case. Oh wait. Oh, I didn't. I'm sorry about that. There. Okay, let's run this. Okay, so looks like it worked. Oh, wait, did I not? I thought oh, it's 2 bars, not 2 thus. Okay, that is not what I intended. 1 second, guys. Sorry about that. I meant to do this actually, and I want the results to still be 6 9 12, but because that is the one that exercises the frequency map correctly. Yeah, there you go, 6 9 12. And that makes sense, right? We have foo bar the other starting at 6. We have bar the other foo starting at 9. And we have the other foo bar starting at 12. Okay, that's great. The I think I do want to submit this, but before that, one thing I realized is that there is one, and this is when I wrote the frequency map logic is when I realized, I don't know if there is a better approach to avoid that, but there is one thing that seems a little bit wasteful to me. Or yeah, and that thing is, so let's take this example. Yeah, this is probably a good example of this. So when we say bar and foo, until then things are great, right? Because bar appears once, foo appears once, and that's good. But as soon as we see this foo, we are going to return false, and then we are going to redo the whole thing for this string, right? A string of 12 from here, right? So initially we took a string of 12 starting from the first index, so that's that. Then we are going to do starting from this index to here, and so on. But we threw away the whole work that we did here. And what I mean by throw away is that we already updated our map to say, oh, one bar appeared, one foo appeared, and we still need one more, or we need two more thus to match. But if we moved the window that we were matching by this, so when we found an extra instance of foo here, right? We know we cannot have two foos. At that point, instead of removing everything and starting over, if we said, okay, hey, let's just remove bar as in 3 letters and do foo foo bar, and that wouldn't work also because foo is still appears twice. But then we would remove foo, and then the foo bar the will foo bar the other will happen, right? And that would have much more efficiently found, so when we find a mismatch of a full word at the end, instead of just incrementing +1 the start index, we say, okay, let's remove one word from the left when one word on the right is an extra word that does not match or is an extra thing. I'm sure I'm not explaining that properly. It's a bit of an intuition, but maybe it's not a big deal and performance is the same. Okay, we'll submit this and see what happens. Okay, not today. Yeah, okay. So it did accept it, which is great, but I think this is probably where our inefficiency lies, right? And I'm pretty sure, actually, I don't know, maybe there are a couple of other improvements we can do. Maybe that is, okay. So one thing I was thinking about is there is a lot of casting back and forth from integer to like integer object to ints, right? I don't think this is going to make the biggest difference, but one thing I was thinking about is what if we do this? We are repeatedly getting from 0 to, int 0 to a capital integer, and then we are adding 1 and so on, right? So what if I cache that? Although I do feel that Java probably caches these integer objects for a bunch of values already, but I'm not sure. I don't remember that from back in the day. Okay, so what if we do this? We say integer dot, I think it's value of or from value or something, value of 0, right? And then instead of doing that, we say 0, right? And this is, I guess, still going to be +1. Yeah, I don't think this is going to help actually with performance. It will work. It is correct, but I don't think it's going to help with performance. Same thing here. Integer. Okay. Yeah, let's see. Okay, so that got accepted, but let's submit and make sure we didn't, or look at the performance improvement if at all. Yeah, okay, that was completely negligible or even noise, right? Okay, so that didn't matter, and I think that's because Java caches these objects already. So that's not helping. Another thing I was thinking about is instead of the hash map, we could have an array which keeps track of like the frequencies and the index into the array could be in the hash table. But I don't think that's also going to matter because you're still doing hashing with a string at least once. In that case, we would avoid hashing with a string twice, uh, but I don't think that's going to move this number much. So I think the only approach that is left to see if it improves performance is the thing I was talking about, which is instead of moving our window on the string. Okay, so let me try to explain that one more time, and maybe I will actually create a separate video on that because this video has already become too long. Yeah, I will, but let me try to explain just one last time what I was thinking, right? Why this is probably not the most performant way. So what we are doing is, given our main string, so let me go back to the example. So given a string like this, okay, our approach currently is that you take all these, actually I do have it written up there. Okay. Yeah, but our approach is that we are taking all these substrings, right, of length 9, right? Instead, what if, actually this is a great place to show you guys what I'm thinking about. Instead, what if we did the following? Instead, let's say we do this, and if that doesn't work, you actually move to 3 to 12, actually 11, right? And that will be foo bar, right? And the reason 3 is the length of every word in the words array, right? And so yeah, and then 3 to 11, and then 6 to 6 to 8, and 6, 9, 6, 15, right? 14, 6 to 14, right? So foo bar the, actually that is what will happen. Foo bar the, and so on, right? So this will become true and so on. And then we run those. So our window of the window that is of substring, that is on substring, is moving by 3, which is the length of the word. But then we have to consider also all the other windows. So we have to do that, right? 1 second. All the other start indices, not other windows. So the window size is still the same, 9. But instead of doing like, so 1 second. So S is, oops, not that. Okay, and then the other possibilities are 1 to 9 and so on, right? 1 to 9 and 4 to 12 and so on, right? So those are the other windows, and we need one more, which is 2 to. And 3 has already started here, so we need the same stuff, but here we say 2 to 10 and 5 to 13 and so on, right? And if we do this, then we can make it more efficient. We are still doing the same number of substrings and figuring out, but we can more efficiently figure out in some cases, because when we peel off an entire word from the left side, if the right side was extra, that doesn't reset the whole word frequency map. Anyway, I'll try to explain much better in the next video. Sorry this video became too long, but it was a hard problem. I think it took us some time to really step by step implement correctly and not get lost in a lot of details. So, but hopefully it was helpful to you guys. If you like what I'm doing on this channel, please consider subscribing and please hit that thumbs up button on the video. See you guys next time.